Good morning or good afternoon. We are going to start word problems with systems, and we're going to start with mixture word problems. And number one says candy is worth $1.05 a pound was mixed with candy worth $1.35 a pound to produce a mixture worth $1.17 a pound. How many pounds of each kind of candy were used to make 30 pounds of the mixture? Okay, so first of all, we're going to let X represent the candy. That's $1.05 a pound. Then we're going to let Y represent the candy. That's $1.35 a pound. So remember back whenever we talked about each and per as being a rate of change or the slope. So this is going to go back and reiterate what we talked about then, because $1.05 a pound means each pound. So we can put an X for a pound, and then the candy that's $1.35 a pound, we can put a Y for each pound. So we can represent those different types of candies, which we can't differentiate any other way. Okay, so we have $1.05 times X, and it's mixed. So whenever you mix something, that means you're going to add it. So plus $1.35 of the Y is equal to a mixture. Now you're going to mix the X and the Y together. That is $1.17 a pound. So when you mix it, it's going to be X plus Y is going to equal that dollar. Well, you got a mixture, and it's $1.17 a pound. And remember that this $1.17 is also your rate. So X plus Y with your mixture. So $1.17 X plus Y. Okay, so then the next piece is asking you to find how many pounds of each kind of candy were used to make 30 pounds of the mixture. So you're going to mix it up, so X plus Y, and we're only allowed to make 30 pounds of each types of candy. So we turn to our Desmos, how we've been solving systems, and it was $1.05 X plus $1.35 Y is equal $1.17 times the mixture, which is your X plus Y. Okay, the other equation that we come up with is the mixture of the candy, X plus Y is equal to 30 pounds, and that's all we get. And you can see that we have an intersection, and at the intersection we have 18 and 12, and remember that X represented our $1.05 pound of candy, and our 12 represents our $1.35 pound of candy, of the different types of candy. So we're going to come back here, and it says how many pounds. So we're looking at, so it was 18 pounds for the $1.05 candy, and 12 pounds. Okay, sorry for that interruption. For $1.35 pounds of the candy. Okay, now let's take a look at number two. Number two is talking about peanuts is worth $2.25 a pound, were mixed with cashews worth $3.25 a pound to produce a mixture with a $2.65 a pound. How many pounds of each kind of nuts were used to produce 35 pounds of the mixture? Okay, so we can make X representing peanuts. Y is representing cashews. So we're going to do the same thing that we did a few minutes ago. It said peanuts were $2.25 a pound, which is my X, and $3.25 a pound for cashews, and a mixture X plus Y of $2.65. So we're going to have $2.25 X, and this is still our rate of change. These are our two slopes, is equal to 265 X plus Y. Okay, so we have our first equation. Now, since we have two variables, remember we need two equations. So our other equation is going to come from how many pounds of each kind of nuts were used to produce a mixture of 35 pounds now of the mixture. So we're mixing again. So mixture is X plus Y is equal to 35. Okay, go back to Desmos. And okay, let's go ahead and pull up our bottom part, and we're looking at $2.25 times X plus $3.25 times Y equals $2.65 of X plus Y, because there's your mixture. Then we're going to go down to the next line, and the mixture of the nuts is worth 35 pounds. Okay, and we want to click on where they intersect, and we're looking at 21 pounds of the $2.25 of, or excuse me, for the peanuts, and 14 pounds for the cashews. And if we add 21 plus 14, we get our 35 pounds. So let's go back. And we're looking at 14 and 11. Oh, 21. Okay, 21 pounds of peanuts and 14 pounds of cashews. And there's your answer. So number 3 and 4, you can go ahead and work on and do, and I think you'll be okay from the examples that were given to you. And also there are 4 on your homework to do. So you have 6 total of these types of system word problems. Have a good day. Okay, welcome back. We're going to talk about money word problems now. And it says the cost of 3 boxes of envelopes and 4 boxes of note paper is $13.25. 2 boxes of envelopes and 6 boxes of note paper cost $17. Be careful, because sometimes they will throw words in there that mean the number. So for example, 2. So I know some of you are used to looking for numbers, but they're not always there. So you need to look for words that represent numbers in these word problems. So find the cost of each box of envelopes and each box of notebook paper. Okay, so we're finding the cost. So our answer is going to be in money. And whenever we're talking about the cost in money, remember, round to 2 decimal places for cents. So the cost is the cost of 3 boxes, and we don't know how many boxes of, well, we know there's 3 boxes of envelopes, but we don't know how much they're going to cost. So that's going to give you your X plus 4Y of your notebook paper. So over here we may want to write X is equal to envelopes and Y is equal to note paper. Okay, which is equal to $13.25. So let me box that in, and that did not happen. Okay. And let me group it so I can move it out of the way. Okay, now you know that we have two unknowns, so we need two equations, and then the other ones, and then the next sentence allows us to set up our next one, which is two boxes of envelopes. Remember, envelopes are our X, plus three boxes of note paper, which is our Y, is equal to $17. All right, so now we have two equations, which is 3x plus 4y is equal to 1325. And we have 2x plus 6y is equal to 17. We go straight to our Desmos, clear out what I did a few minutes ago, and we're going to bring it up as 3x plus 4y is equal to $13.25. Go down to the next line, which is 2x plus 6y equals $17. So now, like usual, we're going to find our intersection. And okay, notice that I am zoomed way out, and it looks like there's only 2 points there. Actually, there's 3 points there, because if you click on it, it gives you your y-intercept and your x-intercept, and that's all you see. But that doesn't make sense, because we're trying to figure out the cost of each of the envelopes and the note paper. So if you hit your home button, or just press your home button, it goes from -10 to +10 as a scale on your Desmos. So now we can see that these 2 points have been separated, and the one that you want is where where the 2 lines cross. So make sure you zoom in, zoom out, trying to figure out where they cross exactly, because you can see that it was giving me the y-intercept and the other point was the x-intercept, but we do not want those 2 points. We want where it crosses, which that means $1.15 for envelopes and $2.45 for note paper. So just keep that in mind. You may have to zoom in or zoom out or press your home button before you can find your answers. So for envelope was $1.15. $1.45. So these are actually set up a little bit nicer and a little bit easier. So let me make sure that I got that right. Yes. Okay. Okay, going to number 2. Number 2, we're talking about small paper clips and large paper clips. And you just read it right off. It says the cost of 8 boxes of small paper clips is your X. The large is going to be representing your Y. So you're looking at 8X plus 7y, because you're buying both small and large, and so that's the reason why you're using addition, is equal to $44.95. 5, there's that word again. You got to be careful with that, because some people don't see it, but it's there. So it's the beginning of a sentence, so then most time they'll use a word for the number instead of the number for the number. They'll spell it out to you. So we have 5x, which is your small, and 3 boxes of your large. And be careful, sometimes on the state test they will switch those to make sure that you're paying attention. So make sure that you read small is your X's and your large are your Y's. The second sentence they may switch it around on you, so make sure, don't let them trick you. You be smart and watch that happening. Now we got to find the cost. So now we're still rounding to the nearest cent. So we're looking at 8x plus 7y is equal to $44.95. And 5x plus 3y is equal to $22.80. So you go to your Desmos, clear out what you have, and type in 8x plus 7y is equal to $44.95. 5x plus 3y equals $22.80. And there again, make sure you see the intersection, okay, of the two lines. And if you ever get a negative number, then you know that money cannot be negative. So maybe you type something in wrong. So I always go back and look at that. And it should be two positive numbers. So we're looking at $2.25 for small and $3.85 for large. I want to go back. Oh, here we go. Okay. So $2.25 for small and $3.85 for large paper clips. Okay, welcome back, and one more piece of information for word problems of systems. Now, these are number problems. It says the sum of two numbers. The sum tells us to add, okay, of two numbers. We don't know what those two numbers are, so we're going to make them x and y. So x plus y, the sum is equal to 18. And their difference, the difference tells us to subtract. So we're going to subtract the two numbers, and we're going to set them equal to 12. Well, now we have our system set up. We have our two unknowns. We have our two variables that we're after again, x and y. So we're going to go to our Desmos, and we're going to add the two numbers, the sum, and we're going to set it equal to 18. And we're going to subtract the two numbers. We're going to set it equal to 12. Okay, so here we have to move Desmos around till we find the intersection, or you can zoom in and zoom out. I could see it, so now I see where they intersect. So I'm looking at my x being 15 and my y being 3. And these are a little bit easier to check, and we can say, okay, so x, so one number is going to be 15, and the other number, which is y, is going to be 3. So we can say, okay, 15 plus 3 is equal to 18, and then 15 minus 3 is equal to 12, and it checks out. Okay, number 2, we're going to treat it the same way. And it says the sum of two numbers is 34, and the difference is 14. So we go to Desmos, clear it out, and we have x plus y equals 34. We have x minus y equals 14. You can sort of take a hold and drag Desmos around again and find the intersection. Intersection of the two lines where the blue and the green come together is 24 and 10. So we're going to go back and we're going to say, okay, x is 24 and y is 10. And you can always check this. 24 plus 10 is equal to 34. 24 minus 10 is equal to 14. And that is it for today. Thank you. Have a good day.